All right. Good evening, everyone.
Good evening.
Oh my God, right. That's what I like to hear. All right. So, well, first of all, Happy New Year. And we're excited to get the new year started with our first meeting of 2024. So, there's a lot of new faces here. So those of you who know, my name is Michael Redlick. I founded this crazy Java group back in 2001. And we went as a nonprofit just over 3 years ago. Barry Bird is running the operations. He's one of the other directors, and so is Chandra Gunter. And then Paul is not here tonight. And then Scott Selikoff is one of the leaders. So that's the cast of characters, as it were. So yeah, so we usually thank our sponsors and talk about what may be new in the Java space and all these things. So our silver sponsor is Azul. They are the makers of Azul Zulu, their downstream distribution of OpenJDK. And they were the first ones who actually implemented their downstream distribution with crack, not that kind of crack, but coordinated restore at checkpoint, which is a way to speed things up and have your startup time down to 0. Bellsoft follows suit with another few months later. Our partner is DevNexus, and this is run by the Atlanta Java User Group. This is one of the up-and-coming premier conferences, which will be held in April of this year in Atlanta. And our per meeting sponsors is JetBrains. Those are the folks that actually make the IntelliJ IDEA IDE, along with WebStorm, PyCharm, and a whole slew of others. And also need to acknowledge Jakarta EE and the Eclipse Foundation. They provide the Crowdcast hosting for Java users groups. All right, what's new? Jakarta EE 11 is scheduled to come out in June or July of this year. The Milestone 1 release was just made available right before Christmas. So there'll be a Milestone 2 sometime in maybe February, early March, and there are 16 specifications out of the 42 that have planned updates. Java 22 is scheduled for GA release in March. I believe it's March 19th. Ramp down phase 2 was just implemented, which is just a further refinement after ramp down phase 1 last month. The feature set is frozen. There was an exception to that last year for JDK 21, but that's a long story. And but yeah, so this is further refinements with bugs and everything else. So, and then JEP, or JDK enhancement proposal number 455, was just targeted for JDK 23, which is scheduled for September of this year. So we'll start seeing more of these features being added for JDK 23 in the next few months. And I believe it's June when they'll have that ramp down phase 1. There's a 1 billion row challenge, which is really cool. This is Gunnar Morling who started this. I want to say about a month ago, maybe a little more. And he's challenging people to write a Java program with 1 billion entries. So I can provide a link to everybody on that. There will be an InfoQ news piece on this hopefully sometime this week. So you can look for that, to read more about it. And then submissions are due by the end of the month. And calling all students. How many are students here? Look at that. No, Chandra, put your hand down. Oh, that's awesome. Thanks for coming out. It's great. So anyway, we had lightning talks by 3 students. Naria, right? Naria, right? Yeah, she was one of those 3 students who did a lightning talk in November of 2022. And it's like 15, 20 minutes. So we're soliciting your interest to participate. We'd like to do this for March of this year. And then have after the 3 or 4 students, then have a talk by Chandra after that. So that's our plan for March.
It's better to go to the experience you can learn, and I'm sure if you have any questions or have never done it before, we can have them.
So just see Professor Bird or Professor Nayan. if you're interested. I'm sure you'll hear more about that as well. So, and I meant to add another group here too. On our website, we have Friends of the Garden State Java User Group. We just added Pittsburgh and then Transylvania, believe it or not. So one of the other InfoQ editors is out of Romania. So he's part of that group. So I updated the website accordingly. All right, so much for me. All right, so we're happy to have Jim Bethancourt. I think you're from Texas, if I'm not mistaken.
Yes, I'm from the Houston area.
You guys had a deep freeze.
Yeah,
we
survived
leader
this
of the
time,
Houston Java User Group and a principal consultant at Improving. He has been a software developer for 15 plus years. Jim enjoys writing great software and helping others do the same. In his spare time, he enjoys spending time with his wife and 5 children. So yeah, and you're a young guy, Jim, so I'm sure your kids are young, right? So
yes.
Yeah. So anyway, without further ado, let's welcome Jim.
All right, thanks so much. All right, let me know when y'all can hear me. Can y'all hear me okay?
Yep, we can hear you.
Okay, great. Let me go ahead and share my screen then.
Yep. You can, okay.
Oh, shoot, one. See, okay, there we go. Share that. Okay, super. So as Mike said, my name is Jim Bethancourt. I am a principal consultant at Improving. I've been doing software development for, even though I said 15 years, it's closer to 20 years. Most of that's been writing Java software. I love it. And I've been at Improving for, I guess, about 3.5 years now. I joined in the middle of COVID. It's a great place to work. I really focus on trust and making it consistently wins best place to work awards. I just can't say enough good things about it. It's really something else. It's a very unique culture. It's really, really good. Again, I can't say enough good things about it. One nice thing, we get paid a few extra bucks every hour we spend working on open source. So just kind of as a side projects, things like that. It's pretty rare that we actually work on open source tools, but we work with them plenty. Just like most modern software development has. A little bit about me. Also, like Mike said, I'm a husband and a father of 5 kids, and I'm interested in software design, software engineering, and economics. This is really the interest in economics is what really grabbed me and gravitated me towards creating RefactorFirst, because I wanted to be able to use my time effectively and have a good impact, a meaningful impact with the time and the work that I do. And it's a very distinct possibility. You may hear my children in the background. My youngest doesn't not have much of an inside voice, so you might hear him. So the struggle is real. So modern software development can be really hard, especially if you're working in a large organization. So I've worked in or directly in or adjacent to large code bases, anywhere from 250,000 lines of code to 2.5 million lines of code. It can be overwhelming, or you can get overwhelmed. You find yourself getting overwhelmed very quickly, and you find yourself kind of almost feeling powerless. I've also worked with a number of tools. IntelliJ is one of my favorite, but I've worked with a number of code analysis tools, a lot of them static analysis, and I would find myself overwhelmed, feeling unproductive, and ultimately feeling frustrated. And so one day, the CTO of the company where I was working said, "Hey, Jim, I want you to focus on technical debt." I didn't know exactly what he meant, but I went to literature and I did quite a lot of searching and found a paper. And that's what RefactorFirst is based on, as an academic paper. So really, I would find myself again overwhelmed, feeling unproductive, feeling frustrated. And this wasn't fair to me or to my family. I would come home frustrated, and I would find myself yelling at my kids. Really, I mean, not like not necessarily yelling this, but losing my temper easily, much quicker than I should have, and it wasn't fair to them at all. I couldn't be a good father, a good husband like this, and so I had to do something about it, and so I did. Large code bases are also painful. They often sprawl. You have different people touch a code base. They have different ideas, different designs, different ways of how they want to do things. And because of this, frequently there's no cohesive way of doing things. And as a result, developer productivity is poor because somebody says, well, hey, you know, this class needs that thing. Well, or we need this feature. Well, let's just go at it over here. And that's kind of how code bases tend to grow. The app that I was working on at my last job, in a bank, a large bank, the largest class that kind of did everything was at least 5,000 lines long, and it was a nightmare. And yeah, that's all I'm gonna say. But also the other tricky thing is that in large code bases, developers and architects may not be able to identify the root causes of degrading team productivity. This is because they have a job to do to actually deliver features. And it's hard to think about what is slowing down team productivity. Maybe changing requirements, yes, but frequently it's just that the code is hard to get through, hard to read. It's hard to understand what it's doing. And this is because code isn't very cohesive. And so the other tricky thing is, as software developers, is that our customers, our product owners, our scrum masters, our managers, they all expect the same velocity, the same level of output as the code base grows. And if your code base sprawls, then change is harder, builds take longer, and testing is more difficult if it's poorly designed. And so we need to have something to tell us, hey, this is where you need to focus your time if you want to start making things better. So Agile is a great process. We use it. I love it. But there are a few problems with it. So Agile process is focused on visible value. Features are a form of visible positive value. This is things that users can go click on, basically, or things that users can interact with, such as, or not users, but other developers can interact with, or maybe users through APIs, through web-based APIs, for example. And bugs are a form of negative visible value because it's costing you money whenever you have to work around it, for example, as a user, because it doesn't do what you expect, or maybe that feature doesn't work at all, and so you have to resort to manual pencil and paper, or the old process that you use. You have to go walk over to somebody's desk instead of clicking send on your email or something like that, you know, for example. That's a rather extreme one, but that's an example. So tech debt is invisible negative value. So whenever technical debt has sort of found itself in your code, when you find technical debt in your code, it takes longer for you to do something, to accomplish something as a developer. Whenever you are working in your code base, and positive and visible value would be architecture and frameworks and libraries that you're using. So if you use something like Spring Boot, or if you use Java EE, those are both, or maybe Micronaut or Helidon. I forget all of the different libraries and frameworks that are available in the Java ecosystem. It's great. But so those are all forms of invisible positive value. They help you to become more productive much faster than you could have been when Java was first introduced. They take care of a lot of the boilerplate code for you. It's really, really nice. but nobody thinks of those as positive value. So again, tech debt is invisible negative value. And as a result, it's hard to identify and prioritize, because what goes in the backlog typically, features and bugs, and that's it. And architecture is kind of just a given. It's like, okay, well, let's stand up the project. Okay, well, let me go generate a Spring Boot project using start.spring.io, for example. And so then voila, you have an MVP, and then you can iterate on that. But with invisible negative value, it's hard to identify and prioritize, because there is no visibility. It doesn't have any visibility. And so it's hard to point to. It's hard to say to your product owner, hey, look, this thing right here is causing us to slow down. And they can say, okay, well, it's code. I don't care. It's your problem. But believe it or not, and so as a result, they don't really take ownership of it. They don't really see that it's slowing down the feature delivery of the team. And as a result, it also doesn't end up in the backlog as a prioritized item. And so so what is important should get worked on. So if the process is slowing down, you need to identify what it is that is causing you to slow down and remedy that. Hopefully that can come out in retrospectives, but it may not. And so there are many code analysis tools available. Some of the better known ones are SonarQube, PMD, Find Bugs, or now Spot Bugs, and then Google Error Prone and CheckStyle. And there are a lot of others as well that all perform static analysis. Some work on source directly, some work on bytecode, but they all produce roughly the same ideas. And they're quite nice, but you can often find yourself overwhelmed as a result, especially if you're working in a large code base. You kind of go, I have 300 highs and 20 blockers. Okay, this is really bad. And also, change history is not taken into account whenever you work with these tools. And so you don't have quite as much context as you could if this change history were taken into account. And you're also frequently these tools focus on what I like to call tactical improvements rather than structural improvements. They don't help you to develop an overall strategy of ordering of how to go about addressing them. Just they lump them together into, say, blockers, highs, blockers, criticals, highs, mediums, and lows, for example. But they don't talk. But they only specify severity, but nothing more granular than that either. And also they can be kind of silly sometimes. Like, hey, well, you're not using the return value of this method. It's like, well, okay, I don't really care about it anyway. So it's like, and it's not causing a maintenance problem either. So it's just noise. So they're also again, I just mentioned this, but they're prioritized by severity, not by effective use of time. And last but not least, they're also developed only on a developer persona. But if you can focus on, so that's again what RefactorFirst I want to aim to remedy with RefactorFirst. And if you have any questions, feel free to speak up. So I don't know, you mentioned there are students there, so there's a product owner. So for those of you who don't know what a product owner is, they basically tell the team what to work on. It's not the manager so much as the product owner that tells the team what to work on. And the manager's job frequently, even though technically there's not supposed to be a manager in Agile, they do keep an eye on team performance and make sure that folks are doing their job and they're productive. And ideally, in an ideal world, they help the team to stay productive. So architecture analysis tools. There are architectural analysis tools available. This one is from a company called Hello Tomorrow. Great company. The founders come and presented at the Java user group meeting before. Very friendly guy. He took an analysis. These tools they create and they identify dependency cycles. However, the output, as you can see here, is often overwhelming. This is the Jenkins codebase. I can't remember exactly when it was. This is a screenshot from the blog that they wrote. And so I don't know if you can decide where to start working, but I sure can't. I just see that and I go, oh boy. And that's about it. So change history in this case is not taken into consideration. So you lose a lot of context whenever you don't have change consideration, whenever you don't have change history incorporated into the analysis. And there again, as I mentioned, there's no immediate indication of the best place to start. And frequently when you use these kind of tools, they say that the ideal use is at the beginning of the project. And so it makes me leave. For me, when I hear that and I look at a code base like this, it makes me feel a little bit like a chump, because like, well, okay, yeah, I guess you're right, but what now? So it's hard. It's a hard pill to swallow. There's also source code repository analysis tools. They perform powerful Git history analysis, but they often focus on the raw churn and the PR cycle time, as well as the performance of individuals as measured by how many lines of code they're writing or how many PRs they're reviewing. But if you ask me, raw churn is not an ideal measurement. It's not really precise enough, believe it or not. And then also the performance of individuals is not ideal, an ideal or fair measure of time either. Because what if an individual is helping a lot of other individuals? Let's say they're pairing, and so they don't actually perform the commit themselves. And I've only rarely seen co-authors mentioned in commits. And so as a result, the individual may not get credit for that line. And so what should be really focusing on is the performance of the team, not performance of individuals. Because people can lose jobs because of this. Whenever, I mean, I'll be honest, I've lost a job because of this, because they had a line of code measurement tool, and at this same bank where I worked on this tool, and they said, well, Jim, you're not putting as many lines, you're not writing as many lines of code as younger developers, and it shows that you have a lack of leadership. Like, excuse me, how could you say this? But that's how they measured it. So it's really awkward conversation. And many of these don't identify root causes either, at least not the real root causes of the problem. And again, also these are also tend to be prioritized by severity, not by effective use of time. So again, none of these tools address time scarcity. The fundamental economic problem that really faces all teams is how to deliver more features faster, given limited time and a limited team size, because we all have to operate under a budget. And so how do we as developers make the most effective use of our time, while also keeping our mental health intact and being able to enjoy life instead of stressing out and feeling overwhelmed and frustrated all the time? So the answer is to increase velocity. So we can do this by introducing and having to fix fewer bugs, we can reduce, if we can reduce regression cycles, we can increase our productivity by actually delivering more software. And we can also avoid changing existing classes. Classes, say large classes, typically, if one line changes, they say, oh well, we have to perform regression cycle on the entire class and all the functions that class touches, and to also have a strongly modularized design. So we can do this. We can isolate change. We can isolate the need to test to a specific feature very easily, and we can again increase our productivity and our velocity. And this eventually tends to lead to microservices in a healthy environment, but it doesn't have to. They can be healthy monoliths as well. So why refactor first? As you can guess, design debt slows teams down. This can be in the form of large classes. This can be in the form of dependency cycles between classes. This can be poor communication. If you've heard of Conway's Law, that basically says that the number of teams that are involved in an effort will lend itself to having that many modules, basically, of the software end result. So I also wanted something to be easy to understand by everyone, by developers and by non-developers. Again, as I mentioned, most tools are targeted only for developers, but I wanted something to be able to communicate to product owners, to managers, to scrum masters, to executives as to how software invisible negative value in software needs to be prioritized accordingly, and prioritized against visible value delivery. And also, again, I wanted to provide actionable guidance. The code the tool that I showed you, Structure 101, that output, it gives you a great picture, but not a lot of ideas of where to start, where to effectively spend your time to start pulling things apart. And there are other tools out there as well that are really good. I've used Structure 101 and Sonograph. They're both great, but again, they don't really provide a lot of actionable guidance of here's where to start, here's what to do next, here's what to do next. And that's what I wanted to deliver and to provide to folks. So I also wanted to, again, make the best use of my time. And so also sometimes with good teams, okay, maybe you underestimated a little bit, overestimated a little bit. So you have some extra time at the end of your sprint, and you want to do some work to chip away at some of the technical debt. So whenever this is the case, you can run RefactorFirst against your code base, and you can see where you can apply that extra time that you have to start to pay down some of that technical debt. Or maybe your team is wise enough, your manager is wise enough to plan maintenance efforts and to say, hey, look, let's go ahead and let's tackle one of these classes a sprint, or start to, for example, that might be one way to do it, and start to pull apart these God classes and focus on one class each sprint. Again, if there is a need for it. So I'd like to talk about what RefactorFirst is, but first a little bit of background. So there are two strategies to pay down debt. So if you ever talk to a financial advisor, they'll tell you there are two different ways. The first is called the snowball method, where you pay the smallest debt first. And the idea is to tackle the easy debt first. So if you have three debts to pay off, you have a $200 debt, a $1,000 debt, and a $5,000 debt, they say, okay, pay down the $200 debt. It'll help you build momentum. You feel good about yourself and feel that, yes, you can do it. And then you can start to pay off the bigger debts and work your way towards the bigger numbers. The other method is called the avalanche method, where you tackle the highest interest first. This takes discipline and endurance, but it ultimately minimizes the interest, and it minimizes the amount of money that you pay on your debt. So how about let's do both. Let's start with the small high interest debt. So in our code bases. And so we do that by looking at the smallest classes that have the highest churn. I'll go into this in just a minute. So first, I'd like to talk about what is a God class. So anybody here heard of God classes? Anybody? Raise your hands. I can't really see anybody, but if not, so I'll cover it. So they tend to heavily access data of other simpler classes, and they're also large and complex. And last but not least, they have low cohesion between the methods belonging to that class. So particularly for access to foreign data, they talk to 5 or more almost helper classes, and they have 46 or more non-trivial methods, and and for any method, so you have almost like tight class cohesion. It means that when it's low, it means that there's really almost maybe like 2 or 3 classes living inside of a single class. And so what you can do ideally is pull apart that class into 2 or 3 or more classes. So class cohesion is whenever one method, if you call one method, it'll call it's related to at least a third of the classes, a third of the methods in a class. So in this case, when class cohesion is less than a third, that means that that any one method has to do with less than a third is related to less than a third of the methods in the class. So if all 3 of those conditions apply, it's a God class. And this concept came from a great book called Object-Oriented Metrics in Practice from Michel Lanza and Radu Marinescu. It was published in 2004, if I remember right. So it's quite a good book. If you're a grad student, you may want to take a look at it. So why focus on God classes? So they are 5 to 7 times more change prone, in part because they're so large. They say a lot of times what happens is folks say, hey, well, we got this class, and the thing that we want to add has to do with that other stuff, so let's just go ahead and stick it in there. And they're also 4 to 17 times more defect prone, which is rather mind-boggling. Again, this has to do to do with size, but it's also rather telling, though, that that they can be 17 times more defect prone than the normal classes. My hunch is that they're so large that it's easy to make a mistake because you're trying to understand what's going on in the entire class. So they are a big offender among code smells. So if you see here, this was a table from the paper comparing 4 approaches for technical debt identification that I read and got the idea from to create RefactorFirst. And but this chart actually they took and they analyzed Hadoop manually from Subversion, and they would take and they would check out Subversion and look at the number of bugs between each class, between releases for each class. They would count them all up, and it was a long painstaking effort. But they produced a great paper. This is really impressive. And so, as you can imagine, Chris Richardson has pointed out that the removal of God classes is very key in the journey to a team implementing microservices. So and again, so why did I focus on God classes? Because the rule was available in PMD. So as a software developer, I try to grab things, libraries off the shelf as much as I can, because I don't want to go and re-implement them. That's I know that multiple people have said the lazy developer is a good developer. And so I, again, try to be lazy. And also it leads to better maintainability of my code base, of the code base of RefactorFirst. However, I am running into issues right now where I need to migrate to the new version of PMD, so I can have it analyze Java 21. But unfortunately, they changed the API, so it is a liability as well. So if you want to use outside code bases, so do be aware of that too. But for the most part, it is well worth it. So this is the analysis of that RefactorFirst produces. This is the graph. It also produces a table that I'll show you in just a moment. And so the idea here is that the effort is on the bottom, and so that's calculated. I think I covered that later. So just in the raw. So this is the godliness of the effort. How bent out of shape the class is. How it tends to correlate strongly with how big it is, and how much effort it would take to refactor that class into a non-God class. So and also so the y-axis is the change proneness, and this is basically how frequently a class changes compared to its peers. So I'll go into how this is calculated in just a moment. But so God classes are also measured by the priority. So I wanted to prioritize this by subtracting the change proneness rank from the effort rank. And I made this actually and this is a slightly old screenshot. I made it easier to look at in a more recent version. I'll show you in just a bit here. But so it prioritizes based on the most effective use of time. And just as a reference, I show the commit count, and so that way you can see it doesn't really care how much a single class has been committed, but how frequently, again, it's been changed against its peers. So in this case, you want to take in and try to make icon set a non-God class and sort of refactor it so that way it's easier to understand first, and then move on to the queue and file fingerprint storage. Now you'll notice that here you have update site and abstract build, and the node and UL validator test both have the same priority. And so what do you do there? Well, you just have to pick one. There's no right or wrong answer. And even then, for higher priority items, you may choose to ignore them and say, hey, look, we're going to be working on q.java soon, so let's focus on that instead. And we'll come back to icon set later when we touch it again. So this is how the results are calculated. So first God classes are identified, and then so the effort, as I mentioned, is the principal. So each God class characteristic is ranked that I had mentioned earlier, and then the ranks are summed individually, and then the summed ranks are ranked. As crazy as that sounds, it works. So so each of these God classes has a weighted method count, and each of these is ranked against one another. And the total class cohesion, each of these has a rank, and they're ranked against one another. And then same thing about access to foreign data. So in this case, these two are 28, this one's 20, this one's 19. So these are all ranked. And then each of these ranks for a specific class is summed. And then so this is the sum of the ranks for all of these for all the classes. And then those summed ranks are ranked. And so this is what is used to calculate the effort in an objective fashion for each of the classes.
Jim, if you're pointing to your slide, we can't see the pointer.
Okay, sure. Let me see if I can activate it just a second here. So okay, there we go. All right. So yeah, let me go ahead and explain that. So first, can you see that? See the
Yes,
laser?
we can see that.
Okay, great. Sorry. So let me go ahead and explain that again. So, so you have the weighted method count. So each of the weighted method counts are first they're evaluated and then they're ranked. So as you can see here, 49 has a value of 3, and 47 is the lowest count, and then 107 is the highest count. So each of these values for the weighted method count are ranked, and then for total class cohesion, these values are ranked, as you see here, and then the access to foreign data count is ranked, and across each of these classes that are identified as guide classes. And so once each of these classes are individually ranked, then the sum of each of the characteristics are ranked, and then they're summed. And so then each of these sums is ranked, and this is what we end up with as the x-axis on that graph. And then change proneness is calculated by taking and looking at the number of commits of a file. So this is the y-axis, the number of commits of a single file, and so the number of total commits in a single file, and that's divided by the total number of commits in a code base since the first commit of that file. So it's looking at the relative churn of that file compared to all of the other files in the code base. And so as a result, this generates an age-independent churn measure. And so this allows for code base for classes in a code base, whether they're old or whether they're new, to be evaluated as peers. And the original algorithm included bug count, but this can be difficult to capture, but could be incorporated in the future, because sometimes bugs are labeled as features or written as features. Then also it would involve a lot of integration, typically with various tools. You could certainly take and look at commit messages. There are some keywords that I could read and look for, such as fixed or bug or problem or things like that. But I haven't done that yet. Even then, it's not a hard and fast rule. So it's of questionable value. And in talking with the person who actually wrote the paper, he said, yeah, most of that's going to just fall out from the change proneness anyway. So so that's again another reason to just stick with change proneness, because you'd almost be double counting if you looked at both the commit that fixes the bug, as well as the message that a bug was present. So to get priority, you subtract the effort from the change proneness. So this is, as a result, the priority is here is 62 because there's a change proneness rank of 65, an effort rank of 3. So that's how I arrived at 62 being the priority here. Does that make sense? Is there questions about that, or did that make sense?
Everybody okay? Or questions? I think we're good.
Okay, great, fantastic. All right. So how do you use RefactorFirst? Well, you can go to refactorfirst.org. I've registered the name. I'd released it, and then somebody came along and snagged refactorfirst.com. Unfortunately, after I'd released it, they saw the name and said, "Hey, that looks like a good name. I'm going to go .com it." So they did. It was used for a while commercially by a tool called Lyft from the company Sonotype. However, unfortunately, it's been decommissioned. It was neat though that they thought to include it. It was really cool. I worked with them for a little bit just as a friendly gesture. But it's the Maven report, and it also works as the Maven goal independently as an HTML report. And so to use it, this actually requires Java 11 now, but also it only requires Maven 3. And that's really it. If you want to use Gradle, you can do that, but you can use it by creating a dummy POM file. Eventually, I've started the process of creating a CLI interface. Somebody actually submitted a PR. It needs a little bit of a finishing touch, but it's in the main branch. And we're up to 050 milestone 1 now. So again, I haven't updated this slide on the deck recently, but it's pretty straightforward to use. And you just execute this goal, or if you install it as a plugin report plugin, it'll run as part of the Maven site lifecycle now. So and I'll show you the let me go ahead and show you the output here a second. So this is the output of the report. And so this graph is interactive. I used Google bubble chart, and somebody asked for it to zoom in. So if you click on it, you can zoom in, and so say if you have a very, very dense graph, you can zoom in if you really want to. But I wanted to make it easy to use. And you're probably wondering why it's so small. This is because I'm on a 4K monitor. I wanted to make sure that it would fit on a high def monitor in case somebody doesn't have a 4K monitor. So that's why I see so much white space on the sides. And then also started. I talked with a friend who's a coworker who's a UI UX expert while I was on the bench last time, and he suggested that I start with the priority of 1 to make it less confusing. So I went ahead and did that, and but you can I still have the change proponents rank and the effort rank here, along with the method count and the most recent commit date and the commit count. And so as you can see here, I've got it to where it'll quickly show the amount of effort and the change proneness and what the priority is. And here are in this case, the circle size. You probably want to know, okay, what's circle size? Circle size is also correlates to the priority. It may eventually correlate with something else. And same thing with the red to green. Eventually what I'd like to do is add unit test coverage metrics, or mutation test coverage metrics if they're available, and possibly testability metrics too. If you've heard of testability, that's how easy is it to test a class. If it's easy to test, then it would be easy to write tests against it, even if it doesn't have any tests written against it. Whereas untestable code, it would be hard to write tests against. So I've also added an additional report for highly coupled classes. So this was another metric that was found basically to be a big problem. So added that, as well as a table with priority as well. So user.java is the problem here. And so is it probably going to want to be your best bet on how to spend your time there. There's some overlap, I'm sure, between highly coupled and God classes, but I haven't taken a deep dive into that. So this is the output of the Maven report. Again, I wanted to make it easy to use, easy to point at, to point your product owner at, to point your manager at, so they can see, yes, okay, I do have a problem, and that I want to make it clear that they own all of this technical debt, because it's going to slow down the future delivery of the team that they are guiding to implement the product.
So Jim, I have a question, but
Yeah.
I want to come over and mute so we don't hear the backup echo.
It's okay. I can hear you just fine. Don't worry.
Can you hear my question now?
Yes, I can. Mm-hmm.
Hello?
Yes, I can hear you.
I guess not. Okay, we're going to have to.
I can hear you.
You can?
I can, yes.
Can you hear me now?
I can hear you, yes.
Now you can, right?
Yes, I can hear you.
Okay. We're gonna have to just live with the echo here.
That's fine. It's fine with me. It doesn't bother me at all.
Can you zoom in to a couple of different features of this chart? Because I see the word effort on the bottom now that I'm very close to the screen, and change. That's it. I'm looking for what are more details about what's going on here? Green, I
Yeah.
guess, means good and red means bad.
Yeah,
Can you just give
basically,
us a better, a more refined tour of what we're looking at?
Sure, yeah. So effort is again the amount of effort that it would take. And the farther away you are from zero, the more effort it will take to make it so that it's no longer a God class. Those three metrics and the algorithm that's used to calculate that effort is here on the x-axis right here. And then the change proneness is again that relative churn that each class has against all the other classes in the code base. And so the higher the churn, the higher this change proneness rank is going to be. And so what you want to do is,
so the size of the circle is the number of methods in a class?
no, the size
No, no.
the size of the class is like basically the visual priority. So the higher the priority, the bigger the ball, the bigger the circle.
Okay, all right.
Yeah. The same thing with the green to red. The more green it is, the higher priority it is.
Gotcha.
Yeah. So I may do some different things with the color and the circle size dimensions at some point, but for now they both represent the same thing. So yeah, so this is again how to figure out visually what your highest priority classes are that you want to refactor first. Any more questions? I'm happy to answer them. We still have plenty of time.
Hello, we've got one here.
Great.
Thanks. We'll try, yeah. Jim, have you applied this analysis to test code, and can you speak to the your experience with that and how it compares to applying this to production code?
Yeah. So I haven't intentionally run through test code, but you can see here this URL validator test and you see here this domain validator test. They're both included in the scan, and they fail the test. They show up as God classes. So you can certainly say that it's possible that God classes, that tests could be God classes, but hopefully you're testing one specific thing, one specific feature in a test, as opposed to 2 or 3 features in a test. But that's a great question.
Anything else for now? Nope. Continue.
Okay, great, thanks. So all right. So you're probably wondering, okay, well, now what? I run RefactorFirst, and I've got the analysis of what I should work on first. But now what? So there's a great plugin in IntelliJ called the Method Reference Diagram plugin. And let me go ahead. This is RefactorFirst. Let me go ahead and pull up Jenkins. Just a second. Right here. And I'll open up in a new window. Move it over. And so let me go ahead and pull up, say, icon set. Oh, wrong one. Okay. So here's icon set. It's not tiny, as you can see. Surprise, surprise. So it's about 635 lines. Again, not tiny. But again, there a lot of it is taken up by Java docs. But see one. Actually, let's take a look. Let's have some fun. We can look at one that's really big, and say maybe abstract build or maybe util.java. Ooh, util. That's a classic one. It's a telltale sign. If a class is named util, or has util in the name, then yeah, that should be a red flag to you. So see how big this one is. So it is almost 2,000 lines. So what do? You want to take and install this Java method diagram plugin, and you can go here and click on show diagram, right click and show diagram, and then Java reference diagram. And hopefully what'll happen in just a second here, it's building it for us. It'll take and build the model. Uh-oh, wait, oh, come on. No, it's supposed to take in, let me try with icon set. Maybe the util is too big. See here. There we go. Okay. All right. So you can see here that we have a class, and it has. I don't know how well y'all can see. Let me see if I can. Nope. I can zoom in.
The writing
here.
is very tiny.
Yeah, it's really tiny. Yeah. So you can see here. Is that
It's
better?
there.
Okay, good.
Well, at least we can see the structure now.
Yeah. So you can see here that there are some methods that call other methods, but they're kind of islands in and of themselves. And some others that call multiple methods, or that are used by other methods. And so some of these you could potentially move out into a separate class, for example. So if we look at, was it Q? I think this one is a bit better. If we look at Q, you can see that there are several different sort of islands almost that we could potentially take and refactor out. And there are different visualizations for this Java method reference diagram that you can use. Okay, yeah. So this is big, but you can see, so we can certainly try to see if we can pull it apart. Don't know if you can do this in a day though, but you can certainly look at it and see that there's plenty of work to be done. So you get the idea though. You can start here, and eventually what I'd like to do is take and use some other libraries that are available that can do graph analysis, and that can take and identify the class, easily identify the cohesive clusters in a God class, and so that way it can provide guidance on how to pull them apart. So for example, here you can see this group over here, this icons. It doesn't really talk to too much else other than this add icon method. So maybe take and pull it out into a separate class as well, and then it can just simply call this add icon method from that other class, for example. And same thing possibly with this right here, this get icon class spec. And then if this is a field of some sort, this is a map. Okay, that might be kind of a bit trickier, but maybe this core icons. So this could certainly be moved into a separate class as well, because it only talks to a static int that's probably public, and things along those lines. So you can perhaps break this up without having to spend a whole lot of effort. For example, this provides guidance on how to get started. This plugin unfortunately does require IntelliJ Ultimate. However, there is a workaround around that, in that if you want to use the IntelliJ EAP versions, it's almost perpetually in EAP. EAP, if you're curious, it stands for Early Access Preview, and you can use those versions for free. You might have
another thing they can do is come to our meetings where we raffle off IntelliJ.
Yes, that is absolutely correct. That is absolutely correct. So that is definitely another opportunity. I love it. IntelliJ is great. I feel so much more. I feel very unproductive when I'm not using it. Even compared to other modern IDEs, just I don't know. Maybe it's my muscle memory. But there's also, I got to tell you, if you haven't used IntelliJ but you want to use it, say you're coming from VS Code or like in my case, at one point I had to switch from Windows to Mac. So I used a plugin called Key Promoter X, and it would pop up a little notification in the bottom left, bottom right, saying, "Hey, there's a shortcut for this. There's a shortcut for this. You should use it." So every time you do something, it'll tell you, "Hey, there's a shortcut," so you can learn all the shortcuts very quickly. So after you have you can apply this Java method reference diagram plugin, and here's where you get it. I also mentioned it on the RefactorFirst GitHub page or GitHub repo in the README. Let me show you real quick. Actually, let me show that to everybody. So let's see. Where is it? Okay, so here we go. Here we go. So I'll walk you as user through how to use it. It does require Java 11. There was a common vulnerability. There's a CVE or common vulnerability enumeration that was assigned to the library JGit that I use to perform the change proneness analysis. And so I needed to upgrade to the most recent version. If your project is stuck on Java 8, then you can use an older version of, I think 040 was the last one to use Java 8. So if you can and you're comfortable with libraries that use CVE, have a CVSS score of 8.0 or higher, if you're just running it locally, you should be fine. But if you're in a highly controlled environment where you can't, you're not allowed to use anything with higher than with a CVESS score of 8.0 or higher, then you need to move to 050 milestone 1. So you can run it from the command line by calling this Maven goal, or you can put this in your Maven as a Maven plugin as part of the build, or as a Maven report. You can add it to your report plugins right here. You may need to add these plugins as well to your build section, because sometimes if you're using an older version of the Maven parent, then it'll snap at you. And there's also you can, if you just want an HTML report, you don't want to run the Maven site report, you can run just the HTML report as well, and then it'll generate a file called RefactorFirst report. And so what you can do is you can even use this as part of, say, a Jenkins build, for example, or whatever your build pipeline is. You can have it call this goal, and then it'll generate a report.
Jim, you want to enlarge the font a bit?
Yeah, sure. Sorry, my apologies. So it'll take and you can use this Maven goal or the report configuration, and you can have it as part of your build report if you want. Again, I want to make it easy to use. You can also run it locally simply by running this Maven goal, and this is possible because you have your GitHub, your Git repository locally, rather than having it somewhere else. That was a huge innovation that Git allows us to do. I mean, I remember a long time ago, and I'm sure the speed's improved, but Git is 400 times faster than Subversion when it comes to doing any kind of operations, because Subversion, for example, is the repository lives remotely. Whereas with Git, your entire repo runs is available locally, and so it's you're performing file operations rather than network operations. What else? So if your project layout isn't typical, or you're using Gradle, for example, or maybe something else, but you can at least install Maven. You can take and just create a sample Maven and POM file, and then run the Maven goal. And this is possible because PMD operates on source code rather than on bytecode. And so what it does is just simply takes and scans your source code and identifies the God class. And so again, here I mentioned the method reference diagram, so you can take and get to it very easily. And this is based on the paper by Nico Zazworka and his colleagues. It takes some digging to get to this paper presentation. Now I need to update this README, but it is available. Yeah, this is
Enlarge the font again a bit.
sure, yeah, you bet. Is that better?
It's visible on YouTube. It might be difficult for the people here in the auditorium, but we can distribute it on YouTube later.
Okay, sure, you bet. What else? I'd like to incorporate more disharmonies at some point, and also incorporate test coverage metrics and add a Gradle plugin, and also identify class locks and prioritize them. I definitely have a way forward, but also this is a passion project, and it's also a hobby. So I'll work on it from time to time, but I'm not profit motive driven, but I do want to help people. So it's I definitely work on it kind of bursty, but it's something that I certainly enjoy working on. Once I can get upgraded to the latest version of PMD, I'll be a lot happier. So all right. So what else? Let's see here. So future actions I talked about. So I actually already did this one. I implemented the second graph that I showed you where it uses 20 types, and also the ones that have high cyclomatic complexity. This could be a potential red flag either as well for design day. And I'd like to incorporate test coverage and mutation coverage. So if you haven't heard of mutation coverage, it's a pretty amazing concept. What it does, and again, go to pytest.org if you haven't heard of mutation testing before, and it is a working implementation of mutation coverage. So the idea behind test coverage, first, if you're not familiar with test coverage, is you want to see how many lines of production code have been executed across your entire test suite. And mutation coverage takes it a step further. And what it does, it takes and will mutate your production code. And then it will attempt to see if any tests fail. And if so for example, it'll take and turn a plus into a minus, or a multiply into a divide, or if it's if a method is returning an object, it'll have it return null instead, for example. And so it'll check to see if any tests fail. And if no tests fail whenever that mutation occurs, then that line of code is not sufficiently tested. So you're probably thinking, well, this would take a really long time, right? Well, what it does is it optimizes the execution before it ever executes any tests. And so that way it makes sure that only the tests that apply to that line of production code are executed, not all of the tests in your entire test suite for your application. So again, I strongly suggest that you check out PyTest. it is very helpful in finding problems, particularly in business logic. If you have generated code or code that maps stuff, it's not quite as helpful, but for business logic, it's absolutely critical. I also want to improve Git analysis performance. It takes, for Jenkins, for me to run it, it takes a good 10 minutes roughly for me to analyze it locally. But I do remember that on my laptop's also at least 5 years old. So that may be something, there may be something there as well. But I mean, it still gets the job done. So I'm saving money and it'll make performance even better for you if you have a faster computer. So I'd also like to, at some point, perhaps create an IDE plugin and a CLI runner. That's actually in the works. The CLI runner is, but you need to put some finishing touches on it. And then also possibly I'd like to see if I can create sort of a GitHub page that will take and catalog all of the well-known open source libraries and tools, so that folks can not to name and shame though, but to take in and help highlight opportunities where people can get involved in open source projects if they want to. And then also potentially multi-repo analysis. So if you have a team that manages multiple repositories, you want to take in and make judgments across each of those repositories as a whole, not only a single repository. So that way you can make the best decision possible. And also potentially measure metrics in other languages such as JavaScript or TypeScript, potentially through using GraalVM and along with other analysis tools. So this is based on National Science Foundation funded research. Nikos Zizworko was the lead author. He's on the top there, and also Carolyn Seaman, Forrest Schull, and Michelle Shaw were co-authors to Nikos Zizworko's work. And it's just I actually had an opportunity to collaborate a little bit with Nico, and he had some great ideas on how it could be made better, how I could make it better. And he said he was just absolutely over the moon whenever he found out that I was able to implement it. So this is also crazy as it sounds. This is your tax dollars at work. It was about a $500,000 grant that went into that paid for all of the papers that were written as part of this effort to produce them. So again, this is your tax dollars in action for you. Crazy as it sounds. Oops, sorry. And then also, again, as I mentioned, I'm the principal consultant at Improving, and I've been leading the Houston Job Users Group for about a little over 15 years now. H.org is the website. I do need to fix it up though. I've been remiss about keeping it up to date. And also on YouTube, I have a few RefactorFirst talks there, along with other Houston Job User Group talks. I'm on LinkedIn if you'd like to connect, as well as Twitter, and then also on GitHub. And I've also taken and moved the RefactorFirst repository to github.org, github.com/RefactorFirst. You'll find it there. So yep, take a look. And also Improving has talks every Wednesday. So you can check those out. The upcoming talks at improving.com/virtual events. And past talks, I've given a couple, are on YouTube/user/improving enterprises. And that's about it. Enjoy RefactorFirst.
All right, let's thank Jim.
So did y'all have any questions? Or is there any other or are there any other topics that you'd like me to talk about? I know, Michael, you mentioned that this is primarily college students, and you have a number of students in the room with you, and I can talk about some of the concepts that that I've incorporated into the RefactorFirst codebase if you want, or things along those lines.
Oh, that would be awesome. Yeah.
Okay, sure. And there was a question about looks like there's a Gradle folder which is at least the beginnings of a Gradle plugin. Is it right? Yes, it is. But unfortunately, I didn't get too far with that, and Andre Almarai contributed that, and he's really kind and generous of him. But unfortunately, it wasn't quite working out, and so I had to comment out and remove that module for now. Yeah, so let me go ahead and share my screen again, and I will show the RefactorFirst code base. Here we go.
So in the meantime, are there any other questions from the audience here?
Yeah, feel
Oh,
free.
wait,
We
we
can.
got a,
Mhm.
How long did it take to learn other languages? Because you mentioned JavaScript as one of your future plans.
Yeah, no, I haven't implemented, and I'm horrible at JavaScript, so I do mostly Java development. I tend to stay in my lane, as it were, for lack of a better phrase. I do okay. I mean, I can read JavaScript, but if you ask me to write it, I kind of go hello, basically. So yeah, I would end up causing more problems than slowing the team down. But I can certainly write it if you absolutely need me to.
Thank you.
Yeah, you're welcome. Or yeah.
anyone
Any
else?
other?
No. So just out of curiosity, you
Mhm.
had a version 0.4 and then a 0.5 milestone 1.
Yes.
Just out of curiosity, do you know when you plan your next release?
Not at the moment. But at the time I was waiting for PMD, the non-milestone version of PMD to be released, so that way they could finalize their APIs. So that was one of the reasons. That, and also just busy with other hobbies and chasing 5 kids, and youngest is in kindergarten, and oldest is in high school. So definitely got a lot of fatherly stuff to do. So yeah.
I have a
But,
question.
yeah.
Why in the world would you want to have 5 kids?
Whole lot of love. God has blessed us, and I want to bless him back. So what can I say?
I'm sure that's a house full.
It is really a dull moment. Yes, really a dull moment. And we had all this stuff after 1 or 2, right? So
Yeah, our kids are growing, so it's nice that they can just do their own thing. And
yeah.
but yeah, just you might know that I do the weekly news roundup, and I always check your releases page.
Oh, you're too kind. Thanks.
So
I'm really,
so I always
really
add
flattered.
that to that, and then of course once you go 1.0, we'll write a full-fledged news piece on that.
Okay, thanks. Yeah, I need to finalize the API, I suppose. There's a lot of stuff I'd like to put into RefactorFirst, so I'm having trouble as to deciding, okay, well, what's the 1.0, because there's stuff that I want to make it do. So yeah, but I'm not. This is supposed to be a tool rather than an API, so I don't know if semantic versioning matters quite so much. So yeah.
Yeah, and by the way, PMD, I haven't used that in a number of years, but it's good to see that's still around.
Yeah, it is. So a few things that I've incorporated. So let's see here. So I've got let's see what can I talk about. That'd be good. So there's PyTest. I know I'd mentioned that. I don't know if I'm running PyTest here. Let me take a look. So again, you'll see here I have multiple modules. I did this for one reason, to avoid God classes, but also to make it easy to identify what needs to be fixed and what doesn't need. So folks can add features easily, rather. So yeah, I don't think I have PyTest as part of this build, but I do have an effort ranker, and then this is where the magic happens to actually identify the God classes, and then take and add those to the list of God classes. So this will identify all of them, and this is for the CV coupling between objects. And this is the God class runner. And so this is called, and then you have the change proneness ranker, and this is so I to make the guide class rule owner, I did find some somebody who'd blogged about how to write your own rule owner, and then I was able to modify that. For the change proneness ranker, it takes and reads the git logs, and for each class, it basically takes and generates a map of the different classes and how many times they've each changed. And so then so these two are pulled together.
Hey, Jim, I'm
by-
gonna interrupt you for a second. I
Yeah,
think
sure.
The amount of code here is so
So much.
voluminous,
Yeah.
and the font is small.
Sorry
What we
about
may
that.
do is, what we want to do is save a discussion like this for a future meeting.
If you
Um,
want to, I mean,
this
it's
would-
not
this would be
glamorous
this would be
code.
great, but right now
I can't say it's glamorous code. So it's more the output that's interesting than the code itself. Some handy tools though. I'm using Lombok. If you've heard of Lombok before, if you haven't heard of it, it allows you to take and use annotations instead of having getters and declaring loggers and things like that. Some other handy productivity tools. Some of the tests, actually, crazy sounds are actually more interesting than the code themselves. This one in particular, I think it was the change proneness test ranker. I actually had to take and have the tests weight to make sure that the change proneness ranker was behaving like I wanted it to. So yeah, again, the code isn't that glamorous, but it does do something very useful. So yeah, that's about it for the code. Any other questions or any ideas, any feedback on how I can make it better?
yeah, just one more question
Yeah,
is,
sure.
does the world know about this yet, or is it in use in many shops?
Yeah. So let me actually pull up just a second, I'll show you. I'm glad you asked. So I don't know who's using it, but it is being used. Just a second here. Let me do this. Tear off a tab. Hold on. Oh, there we go. Okay. All right. That's what it was. Sorry, Zoom's control panel is kind of getting in the way. So let me go ahead and show you. Make this a bit bigger. Then I'll log in. And I can show you that there's something called central statistics. So RefactorFirst. So here are the statistics. So it's being used. So let's see if we got the plugin itself is being downloaded, I guess, about 100 times a month or so, maybe a little more. Just varies. You can see the different versions that are being used as well. So most folks are still comfortable with using version 0.4, but you have different versions that are being used. So that's the total count of the different versions. So probably these are say different builds that different folks are using. I try to get the word out, but again, it's not always easy. So thank you so much for this opportunity to help get the word out about it.
No, that's this is awesome because I know I've been following, RefactorFirst for a while now. So I'd love to have a chance to really work with it, but maybe that'll come. Any other questions? All right. So Jim, to avoid the echo, we're going to mute here,
Sure, that's
but you
fine.
may not be able to hear me though.
Okay. I mean, but the echo doesn't bother me. If you can't hear the echo, it doesn't bother me.
No, but we can hear
Yeah,
the
we can,
echo.
we can.
You can,
hear the
okay.
echo. Yeah.
We're
Sure,
gonna
got
go muting, and we want to thank you very profusely before we mute it so that you can't hear it.
All right, thanks.
Well, let's thank Jim one more time if we can, so. And, oh, and by the way, we had 25 in-person attendees here tonight.
That's great.
So
That's
yeah,
great.
So,
Fantastic. Well,
And,
thank you so much for
yes.
coming, everyone.
so yeah, you can hang out for a little bit and, until I'm done with my little spiel at the end. Yeah. Yeah. Yep. Oh. No, I have to.
Yeah, probably won't be working on it for at least through May, simply
Yeah.
because I have
Where's the?
a
Oh, here it
Kafka
is.
talk to give.
Oh, this will stop. Yes. Okay. All right. Oh, I gotta. Hold on, one more thing. Oh, am I? Oh, yeah, here. Wait. Oh, yeah, perfect. All right. Okay. I don't think we need to. I don't think I need to. Well, I need for the video, I suppose. But yeah. So at the end of it, every meeting, we talk about some upcoming events and for what we're gonna do and things like that. And then of course we're gonna have the giveaway for IntelliJ IDEA, and then a micro profile hoodie. So coming up, starting Thursday and Friday, is the J Champions Conference. This is a conference of Java champions, and it's a 4-day event, and it's free and it's virtual, all virtual. So Barry and I were both on the steering committee for this, and we have how many talks? 30 thereabouts in the 4 days. So yeah, definitely check that out if you're interested in participating in some way, for watching all the talks. There's an online summit for Java devs. It's was moved from last week to next month. Don't know why, but I'm giving a talk on my Jakarta EE11 at that. This is also all virtual. Of course, when they changed it, I have jury duty that week, so it may not happen. So, but that's that for, yeah, exactly. So the annual Trenton Computer Festival, this has been one of the oldest computer shows that started in 1976. Okay, so I'm sure a lot of you weren't around then. So, but yeah, so this is a 1-day event with a matrix of talks for all skill levels. And there's also some vendors and there's a keynote address and stuff like that. Barry will be, speaking. I will be speaking along with somebody to do some Python stuff. So that should be fun. That's at the College of New Jersey. JD Conf is sponsored by Microsoft. This one is also a virtual event. That's at the end of March. And of course, I mentioned DevNexus earlier. And then upcoming meetings for us. Next month, we have Doug Dreschel, and he's going to talk about Oracle's MERN stack. And I forgot what the acronym of MERN meant. If anybody else knows, then please let me know. But yeah, so that'll be the 21st, same bat time, same bat channel. And then, obviously March 12th, as I mentioned earlier, we'd love to have a few of you, young folks give a lightning talk. And then April is still up in the air. And then Wednesday, May 8th, we have Billy Carando from Oracle. He's a Java developer advocate. And he'll be here to visit with us, Philly, and New York that week. And he's going to update some of his talks, so we'll pick one out. We'll probably circle back in March sometime to get a final presentation. And then we're working to schedule Dmitry Choiko. He's from Bellsoft. And so we're trying to get him for April, but we'll see how that's going to work out. All right, so we have the Friends of Garden State Java user group, as I mentioned. Since we're at the end of the month, most of our friends had their meetings already. So I found a couple that already had theirs scheduled for next month. So the New England Jug is doing theirs on February 8th. And then the Philly Jug on February 20th. Ivar Grimstadt, who was here with us in September, will be there in Philly. Ivar is a recording EE developer advocate at the Eclipse Foundation.